So we were solving about differentiation, right? So this is a given signal and we have to differentiate the signal x of t. Okay, so if you differentiate that signal, you have d by dt of x of t. This is a second problem, okay? So if you differentiate a unit step, you get impulse signal, correct? So here, as you can see, I'll mark it in red, there is a unit step. It's increasing from 0 to 4. Okay, then it's constant, then it is coming down to 0 from amplitude 4. So a differentiated signal will be an impulse from 0 to 4. Okay, then again it's constant, right? From 0 to 2 it's a constant. As you can see here, it's a constant here. So again it will come back to 0. Again at 2 it's coming back 4 steps downwards. So it will come back 4 steps downwards, it's minus 4. This is a differentiation of this signal. Got it? Here the signal is increasing from 0 to 4. So we have an impulse from 0 to 4. Again the signal is constant. So I'm coming back to 0, it's constant. Again it's 4 steps downwards. At 2 it's decreasing the unit step. So here the impulse will be 4 steps downwards from 0. Got it, everyone?
Ma'am, can you repeat it again, ma'am?
Yeah, this is a unit step signal. Okay, if you differentiate a unit step, you get impulse. Okay, so observe here, your signal here, it's a unit step. Okay, it is increasing, the amplitude is increasing from 0 to 4 at the beginning. Okay, it is 4. Later it is constant. If it's constant, you have to come back to 0. Okay, again the amplitude is decreasing to 0 at 2. So you have to go 4 steps downwards. Okay, here it's increasing. So we represent it by a unit impulse from 0 to 4 amplitude. Okay, then by an impulse signal with amplitude 4. Then when it's a constant, you'll come back to 0 again. Again, you have to go 4 steps down at t is equal to 2. Got it?
Yes, ma'am.
So these are some of the simple signals. One more signal I'll give you of such kind. This is just for extra information, okay? So you have to know this. -1, -2. So you have a signal like this. Okay, so we have something like this. So this is 1, amplitude here is 1, here it's 2, and here it is 3. Okay, this is, okay, I'll redraw this part here. The amplitude here is 3. Okay, this is my signal x of t. Now differentiate. Okay, differentiate x of t, you get y of t. That is nothing but d by dt of x of t is nothing but y of t. So y of t is the differentiation of x of t. So now how will you plot? You have to tell me how you will plot. You have unit step, differentiation of unit step is impulse, unit impulse. So what you will do now? How will you plot? So how will be the differentiated version of this signal? So at 2, the signal is increasing to 1. Okay. So you'll have an impulse, unit impulse at 1 with amplitude 1. Okay. And again at -1, again it's constant from -2 to -1. Again come back to 0, it's constant. Okay. Again from -1, you have a unit step signal. The amplitude is increased by 1 unit. So again you have at -1 also you have one unit impulse. Okay, of 1 step. Again it's constant. So again it will come back to 0. Okay. So again at t is equal to 0 you have 1 step. Correct? So at t is equal to 0 we have an impulse of amplitude 1 unit impulse signal, and again it's constant. again it will be constant 0. If the signal is constant, it will be 0 again. Okay. Again from 3 at t is equal to 1, you have 3 steps downwards. The signal is coming from 3 to 0. So from 1, there will be 3 steps downwards. That is -3. Got it? Followed?
Ma'am, last one once repeat now, -3 how?
Yeah. So here the unit step we have staircase type, right? Here you have unit step. Okay, so here you have unit step. The amplitude is increasing from 0 to 1, correct? So you have an impulse here. Again the impulse is constant. So again it will come down to 0 and it will be constant. Again at -1 you have increasing from 1 step, increasing from one step. Okay, so again you have an impulse here. Again from -1 to 0 it's constant, so it will come back to 0 and it will be constant. At 0 again you have 1 step increase, increment of 1 step you have here. So again you have unit impulse. Again from 0 to 1 the signal will become constant. So from 0 to 1 the signal will be constant. At 1 the signal is dropping from 3 to 1, 3 to 0, amplitude 3 to 0. It's coming down 3 steps. So here you have an impulse which is coming 3 steps downwards. Got it?
Yes, ma'am.
Okay, this is one example. I'll show you one more example.
Ma'am, at -1 amplitude must be 2, no ma'am?
No, at -1 there is a change. What is the rate of change? It is only 1 unit, right? So signal is constant, again 1 unit change. Again the signal is constant, 1 unit change. Got it?
Okay, ma'am.
So next is this signal. -1, -2, -3, 1, 2 and 3. So you have a ramp from 3 to 2. Then again the signal is constant. Then again you have a step. The signal is constant, again you have a step. So differentiation of this. So this signal is having both unit step and unit ramp. So d by dt of x of t would be, so 1, 2, 3, -1, -2, -3. So from -3 to 2, sorry, -3 to -2, you have a ramp. Okay. So what is the differentiation of ramp? It is a step, unit step. Yeah, so from -3 to -2, you will have a step signal. Okay. Again, the signal is constant. Okay, so let it be constant. Again, at 1, there is 1 step increment, unit step. We know differentiation of unit step is impulse. So at t is equal to -1, you will have an impulse. Okay. And that after that, the signal is constant from -1 to 1. Okay, so again come back to 0 from -1 to 1. Okay, again there is decrement of 1. So let it come back to 0 and let it be constant. Again we have a decreasing slope. So you'll have a unit step downwards. Got it? Is it clear?
Yes, ma'am.
Okay, like this you have to analyze and do each stage. So whenever it's constant, the signal will come back to 0. Okay, again accordingly how to do. You have a ramp from -3 to -2. So you have a step signal. Again the signal is constant from -2 to -1. If it's a constant, you have to get back to 0 again. Okay, again you have a unit step. 1 step you have increment of 1 step. So write a unit impulse from -1. Again the signal is constant. So come back to 0 from -1 to +1. It's constant, so come back to 0. Again there is 1 step decrement. Okay, so this amplitude is 1 and this is 2. So there is 1 step decrement So from 1, there is 1 step decrement. So the impulse will be, unit impulse will be downwards, -1. Okay, then again the signal is negative ramp. So it is the unit step from -1. From 2 to 3 you have amplitude -1. Got it? I hope I have solved all the types of problems, and one type of problem I had just left. I thought you can do it by yourself, or I'll do one of that problem. Okay, later you can solve problems on that. Yeah. It's energy signal problem. Okay, so given x of n is equal to n from between 0 to 5. Okay, and it is 10 minus n between 5 to 10. It is 0 otherwise. So you have to plot this and find energy of this signal. Okay, so it's a finite duration signal, as we can see here. It's present from 0 to 10. So we shall try plotting this signal and we'll find energy for this signal. So they're telling you it is n between 0 to 5. Okay, so give values for 0. At n is equal to 0, it will be 0 only. At n is equal to 1, it will be 1. Amplitude will be 1. At n is equal to 2, the amplitude will be 2. It is equal to n. Okay, between 0 to 5, the amplitude is equal to n. Okay, so at 3, the amplitude would be equal to, n is equal to 3. This is n axis. This is discrete time signal. Okay, and we are giving values for n. Okay, at n is equal to 0, the signal will be at 0. If n is equal to 1, the signal will be at 1. At n is equal to 2, the signal will be equal to amplitude 2. At n is equal to 3, amplitude will be 3. At n is equal to 4, the amplitude would be 4. At n is equal to 5, the amplitude would be 5. So it is equal to n for less than or equal to 5. Okay. Then after 5, sorry, this is n here. So after 5, the amplitude is 10 minus n. Okay. So at n is equal to 6, at n is equal to 6, the amplitude is 10 minus 6. Okay. At n is equal to 6, amplitude is 10 minus 6. That is 4. Okay. At n is equal to 6, the amplitude is 4. At n is equal to 7. Did I start the recording? Yeah. So at n is equal to 7, that it will be 10 minus 7. That would be 3. At n is equal to 8, the signal will be 10 minus 8. It will be 2 units. At n is equal to 9, it will be 1 unit. At n is equal to 10, it will be 0. And it is 0 otherwise. For all other values of n, from -2 up to -infinity to 0, it is 0. And other values also, from 10 to infinity also, it is 0. This is the given signal x of n. So you have to find energy of this signal. How will you find energy? What is the equation for energy? For discrete time signals? Can anyone tell the equation for energy for discrete time signals?
Ma'am, summation n equal to minus infinity to infinity, x of n whole square.
x power x n whole square.
Modulus of x of n whole square. Correct. But what is the equation for n? For x of n from 0 to 5, it is n, and from 5 to 10, it is 10 minus n. Okay, we'll take that limits for summation. For summation n is equal to 0 to 5, the equation of n is n square. X of n is n. Okay, so x of n square we have in energy equation, so we'll do n square. Plus From n is equal to 6 to 10, the equation of x of n is 10 minus n. That is given in the question itself, right? So that is how we have defined this signal, right? From 0 to 5, the equation is n. From 5 to 10, from greater than 5 to 10, it is 10 minus n. So our signal would be summation n is equal to 0 to 5, it is n. So n square, energy equation should be square, modulus of square. So we have n square plus summation of from 6 to 10, it is 10 minus n square. Got it? Now solve this. So from 0 to 5, you have n square. So we have at n is equal to 0, you have 0 plus if n is equal to 1. So 1 square is 1. If n is equal to 2, 2 square is 4. Then 3 square is 9. 4 square is 16 and 5 square is 25. Plus give values for this n here also from 6. So it will be 10 minus 6 square will be 4 square. It will be 16 plus 10 minus 6, 10 minus 7, that would be 3. So 3 square would be 9 and 10 minus 8 would be 2. 2 square will be 4. And 10 minus 9 would be 1. 1 square would be 1 only plus 0. So what do you get? Add it. So that is your energy.
85.
Yeah, 85 joules. Got it, everyone? It's energy signal, so you got energy finite. What will be the power of this signal?
0.
Power will be 0. For energy signals, power is 0. Okay, and for power signal, energy will be infinity. So this is one type of problem I had missed to solve. And I hope I have covered everything in unit 1. So we'll start with unit 2 today. If you have any doubts, you can ask me in unit 1. So I'll just brief up whatever we have discussed. So we have seen classification of signals. Okay, so we have classified signals into different types of continuous time and discrete time signals. This is a basic classification of signals. You'll be using throughout this course. You'll be having problems on continuous time as well as discrete time. So continuous time we represent it as x of t, and discrete time we represent it as x of n. Okay, next we have periodic, non-periodic signal. So we have found out period for these. Okay, we have identified whether the signal is periodic or non-periodic. If it's periodic, we have found out the period. How did we find out the period? T for continuous and n for non-discrete. So for continuous time signals, we found out what is omega. Omega is 2 pi f. We found out f, and from f we found out t. Correct? And for n, for discrete time signals, we found out the fundamental period n. How did we find out? We found out what is omega. From omega, we equated that omega to 2 pi by n into m, where n and m are integers. Okay. So we found out the period n, number of samples. Okay, and that is about periodic and non-periodic. And we also solved this even and odd component. We found out even and odd component of the signals by using the equation x e of t is x of t plus x of minus t by 2, and odd component was x of t minus x of minus t by 2. We found out odd component of the signal using this. What we did, given a signal, we found out its time reversal x of minus t, and we scaled the amplitude by 2. Here we subtracted x of minus t from x of t, and we scaled the amplitude. That is in case of continuous time signals. In case of discrete time signals, we have x e of n, which is equal to x of n plus x of minus n by 2. Okay, time reversal of x of n is x of minus n. Similarly, x o of n would be x of n minus x of minus n by 2. Okay, this was for the odd component of discrete time signals. And after this, we had seen what is deterministic and what is random signal. Just definitions you have. Okay, deterministic signal can be predicted by the time. Okay, it is a function of time. Whereas random signal you cannot predict. Okay, it's not a function of time. Like outcome of a toss of a dice, outcome of a toss of a coin, or noise from electronic components are all random signals. Your ECG and all are random signals. Okay, and we saw energy and power signals. So what we have seen in energy and power, all the non-periodic signals are energy signals, and all periodic signals are power. All periodic signals are power signals, but we cannot tell all the power signals are periodic signals. Okay, there are some non-periodic signals also. Exception was unit step, U of t or U of n. Okay, so we have seen these things. And we have seen energy equation and power equations for the signal, right? This is the classification of signals which we have seen. And next was operations on signals. Okay, so first this is if x of t is a function, t is an independent variable and x is a dependent variable. Similarly for discrete time signal, n is independent and x is dependent variable. So we have seen operations on the independent variable like time shifting, time scaling, time reversal, and amplitude scaling. So given any function, we know how to do operations on signals, right? If you have been given 2 times x of minus t plus 3, so what do you do first? From the law of precedence, first you will do x of t plus 3, time shifting, then you will do time reversal because there is no time scaling here. You'll do time reversal, you'll take mirror image of that, you'll get x of minus t plus 3, then you'll amplitude scale it. You'll increase the amplitude by multiplying it by 2. Okay, this is a precedence rule. So we have seen problems on this also, and we have seen addition of signals also. Addition, multiplication, subtraction, integration, differentiation. Okay, if you have any doubts, you go through whatever, you listen to the recordings, okay? If you have any doubts, you can approach me, okay? Don't feel free to approach me, you can ask me any doubts, okay? And we have seen all these things. Now we have also seen problems of expressing x of t in terms of g of t, such type of problems also, right? So this is your unit 1. So coming to unit 2, you have systems, okay? We are being dealing about signals only. Now we'll deal about systems. Okay. So in our first class, we have seen what is a system, right? Definition of system we had seen. So what is a system? Can anyone tell? What is a system?
Meaningful information of physical device.
Meaningful?
Information of physical device or component.
Interconnection, it's called, okay? It's a meaningful interconnection of physical devices and components. Meaningful interconnection of physical devices and components is called a system. Okay, what will system do? It will transform signals for various applications, okay? So system is represented by this way. A system has input and output. The input may be continuous time signal or discrete time signal. Okay. If you have input x of t, you will get output y of t, or if you give a discrete time signal, you will get y of n. Okay, this is what we have seen. The system will accept a signal and it will give out another signal which is more desirable than the input signal. Okay. So the system will transform signal for various applications. So we'll be discussing about properties of system. Okay, like we have seen classification of signals, we have classifications of systems also, different types. So we'll discuss about that. So there are different categories of systems. Okay, first you have linear and non-linear system. Next you have memory-based systems and memory-less systems. Okay, then you have time invariant and time variant system. Next we have causal and non-causal systems. Then we have stable, unstable systems. We have invertible and non-invertible systems. We have invertible and non-invertible systems. So these are the different 12 types of systems. Okay, so the definitions for this are easy, but to find the nature of the system is little bit challenging part. So we'll solve problems on every type of system so that it will become easy for you. Whenever an equation is given to you, then you can easily find out, okay, what type of system is that. So we'll first understand what is the basic notation of a system and how it works. As you can see here, we have a system represented by a block here, right? Input of the system is x of t or x of n, and output of the system is y of t or y of n. Okay, so this output y of t or y of n will depend on input x of t as well as the system property or type of the system. Okay, so output y of t will depend on the input as well as the type of the system or nature of the system. Okay, so that is your output dependent variables, that is input and the system property, input x of t and system property. So based on the system and changes produced by the system, the output will have some value. Okay, so we'll try to understand some basic things before going in detail. So we have to know what is present input, past input and future input. Okay, so till here it's clear to you what is the system. System has an input, it has an output. So output is more desirable than the input. So this output will depend on input and the property of the system. Okay, so based on that, we'll try to understand what are the three types of inputs. Okay, so you have present input, past input and future input. So what are these three? So we'll see three cases. So case 1 is y of t is equal to x of t. Okay. Case 2 is my y of t output is equal to x of t minus 1. And case 3 is my y of t output is equal to input x of t plus 1. Okay. So to understand the output is dependent on present input, past input or future input, we have these three cases. Okay, so I will take t is equal to 0 as my reference. Okay, and I'll put it in all these cases. So if t is equal to 0, if I put it in case 1, y of 0 is equal to x of 0. What does that mean? What is the meaning of this? Y of 0 is equal to x of 0. You can clearly see that output is depending on present input. This is present output. Okay, I'm taking reference time t is equal to 0 as present time. So present output, this is present output, this is present input. So you can see that output is present output is depending on the present input. So this is input, I'm sorry. Present output is depending on the present input. Okay, so when t is equal to 0, it's called present. Okay, I'll take this as reference. T is equal to 0 is present time. T is equal to -1 is past input. This is present input I'll take. T is equal to 0 is present input. T is equal to -1 is past input or output. Let it be just the versions. T is equal to 0 is the present instance. T is equal to -1 is past instant, and T is equal to +1 is future instant. Okay, if I tell like that, we are speaking about T is equal to 0 as our reference. Okay, so that means we are at this time instant T is equal to 0, and relative to this time instant T is equal to -1 will be past and T is equal to +1 will be future. Okay, so if you take time instant T is equal to 0 as reference, T is equal to -1 will be past, T is equal to +1 will be future. Okay, T is equal, this is time axis. Time 0 you have, at time T is equal to 0, this is -1, this is +1. If I take reference, my reference as T is equal to 0, this T is equal to -1 would be past and this would be present. This would be past and this would be future. Okay, at T is equal to 0 will be present. Similarly, if I take my reference as T is equal to -1, if T is equal to -1 is my reference, then T is equal to -2 will be past and T is equal to 0 will be future. Okay, did you guys follow? So it all depends on our analysis, okay, and our reference, what we are taking at that point of time. So if I take T is equal to 0, T is equal to -1 will be past and T is equal to 1 will be future. And if I take T is equal to -1 as my reference, T is equal to -2 will be past and T is equal to 0 will be future. Okay, so it depends on our analysis and our reference. Is it clear? So you can see y of 0 is equal to x of 0. Present output is depending on present input. So I'll put t is equal to 0 for case 2. So if I put t is equal to 0 for case 2, my y of 0 would be x of t minus, so y of t is equal to x of t minus 1. So this will be 0 minus 1. So y of 0 will be equal to x of -1. What is the meaning of this? Output is depending on, what is this x of -1?
Past input.
Past input. Okay, so y of 0 is equal to x of 1 is nothing but your present output is depending on past input. So if I put t is equal to 0 for case 3, what do I get? Y of t is equal to x of t plus 1. So y of 0 is equal to x of 1. That means my present output is depending on
Future input.
It's depending on future input. Okay, so output will be y of 0. So present output is depending on future input. Got it? So there are 3 cases. Okay, so if you understand these 3 cases, it will be easy for you to solve problems, okay, on categorization of systems. So what you have to do is basically put t is equal to 0, okay, to the relations given to you, and understand what you are getting here depending on the relations of these. Okay, if y of 0 is equal to x of 0, then present output is depending on present input. Okay, so this will be easy for you to categorize systems. Okay, what types of systems you can categorize using this method, case 1, case 2 and case 3. So whenever you get a relationship between any signal they give you, so put t is equal to 0 first, t is equal to -1 and t is equal to +1. That will be easy for you to categorize systems which are memory systems, systems with memory and memoryless. Okay, and it will be easy for you to categorize causal and non-causal. Okay, so these 2 systems need these three cases. Okay, t is equal to 0, t is equal to -1, t is equal to +1. Okay, we'll see what is memory based system, memoryless system, causal, non-causal and all. So this concept will be helpful for categorizing of these two systems. Okay, for time invariant and time variant systems, we'll see how to implement a delay. Okay, time invariant and time variant. For these two types of systems, we have to implement delay. We shall be seeing that. Okay, and for linear and non-linear systems, you have to understand the principle of superposition. Okay. So the principle of superposition is addition of two laws. Okay, that is law of additivity and the law of homogeneity. So if law of additivity is, if it clears the law of additivity and law of homogeneity, then the signal will, that the system will be linear system, else it will be the linear non-linear system. Okay, if the system or the equation satisfies the principle of superposition, that is law of additivity and law of homogeneity, then you can categorize those systems as linear systems. If not, there will be non-linear systems. Okay, we'll discuss in detail about these. So today is just introduction class for you people, and we have invertible and non-invertible system. Invertible and non-invertible. So we shall see one-to-one mapping and many-to-one mapping. Okay, so one-to-one mapping and many-to-one mapping. So if we understand this, we'll understand what are invertible systems and what are non-invertible systems. So next are stable and unstable systems. Okay, so for understanding what is a stable system and what is unstable system, we have to know about Bibo stability or Bibo criteria. Based on this, you can categorize your system as stable or unstable system. So what is this Bibo criteria? BIBO means bounded input, bounded output. So what is the meaning of bounded input and bounded output? Bounded input means the amplitude of input should be finite. Okay, it should not reach infinity. So if you have a system, so the input is bounded input means, so if you are telling the input is bounded input means it should be finite. This x of t should be finite and it should not reach infinity at any instant of time. That is the meaning of bounded input. Bounded output means the output y of t which you get after giving bounded input should be having finite amplitude and it should not reach infinity at any instant of time. That is the meaning of bounded input and bounded output. Based on this, we shall see if you are giving a bounded input to a system, that is finite input which is not equal to infinity, then you have to get a finite output which is not equal to infinity. It should be finite value output. Such systems are called as stable systems. So if you're giving bounded input and you're getting unbounded output, or if your output is approaching infinity, then it is called as unstable systems. Okay, this is a categorization of systems. So first I wish to start from memory and memoryless systems. Okay, it is clear till here? You're having some idea? So for memory, memoryless systems, causal, non-causal, will be dealing about these. T is equal to 0, t is equal to -1, t is equal to 1. For systems with memory, if your output is depending on past or present, that would be memory based systems. Okay, that is, if y of t is equal to x of t minus 1, or if y of t is equal to x of t plus 1, so you have to put t is equal to 0, t is equal to minus 1, t is equal to plus 1 and check. Okay, if it's memory based or memory less. By seeing only I can tell that it's memory based systems, because my present output is depending on past inputs here. Here in this case, my present output is depending on future values of inputs. So it's a memory based system. Okay. And we shall see what is a memoryless system. If your present output depends on present input, that is memoryless system, because you don't need memory to store past values or previous values. That is called memoryless. Okay. So we shall see the first categorization now. And causal, non-causal, it's similar to that only. I'll tell you when I explain you that. So I'll tell you now only. So why, if just briefly, if your output is depending on present input and past input, that it's called causal system. Okay, if your output is depending on future values of input, it's called non-causal. Okay, so that's the basic definition. And what they'll give you is, they'll give you a relationship between input and output. So if x of t is equal to some equation, they'll give you. Okay, so I'll just tell you an example. Yeah, so y of t is equal to 2 times x of t minus t into integration of minus infinity to t x of tau into d tau. Anything they'll give you like this, or y of t is equal to 2 cos 3t, something like that they'll give you. Okay, in this unit, how you'll get questions, I'm telling you. So this, you have to categorize this as which, for all the types of system, whether this equation belongs to linear system, okay, it's linear or non-linear, it's causal or non-causal, it's stable or unstable, it's invertible or non-invertible, and it's memory based or memoryless. You have to categorize this equation for all these conditions. Okay, you have to check whether it's linear or non-linear. So there are some methodologies to check these relationships. Okay, so we shall see that. So first, what I'm planning to do is, first I'll tell you what the definition, and we'll solve some problems on these memory and memoryless only. Later, I'll go to some other system, linear, causal, or anything. So we shall see some examples on these and try to understand. Later, I'll give you some relationship like this, and you have to classify these signal based on all these conditions. First, we'll categorize and check individually, then we'll see overall equation. Okay, with respect to the system. Is it clear, everyone?
Yes, ma'am.
Okay, so we have some time, right? So I'll start with memoryless now, or next class. Shall we start now? Memory and memoryless systems. And I'll just explain you, then we can solve problems on these. Okay. So memory and memoryless systems are also called as static and dynamic. They are the same. Static means memoryless, and dynamic means memory based systems. So we have seen what is past input, present input, and future input. Okay. So I don't know what is the property of the system. If I have a system, I don't know what property is that system, or what is the nature of the system, I just don't know. I have my input x of t, and I have output y of t, and I have relationship between input and output. Okay. Using this relationship between input and output, I have to categorize this system, what type of system it is. Okay. By looking at the relationship between input and output, we have to find out the nature of the system. Okay, that is the first, that is the motto of this unit. So we have y of t is equal to x of t minus 1. Okay, and y of t is equal to x of t, and y of t is equal to x of t plus 1. Okay, so in this case, output is dependent on past input. present output is dependent on past input. Here, present output is dependent on present input. And in third case, present output is dependent on future input. So, I'll say what is memory and memoryless system now. If your present output is dependent only on present input, such are memoryless systems. Okay? If your present output is depending on past input or future input, they are called as memory-based systems. Memory-based systems or dynamic systems. Okay, in the exam, they may ask you dynamic or memory-based. Memoryless or static. Don't get confused. Both are same. So this is also a memory-based system. Got it, everyone? Definition of memory and memoryless. If output of the system depends on the present value of input, then it is memoryless system. Got it? Are you following, everyone?
Yes, ma'am.
Is it clear? So memoryless systems, I'll write the definition. So memoryless system, in memoryless system, output of system depends only on present value of input. Okay, if you're taking y of t is equal to x of t, the best example for this, your present output is depending on present input. Okay, so this is a memoryless system. There will not be any memory. Okay, next categorization is memory based system. Okay, so memory based system or systems with memory. Okay, so the output of the system depends on past or future values of input. If output of the system depends on past or future values of input at that instant of time, then they are memory based systems. Okay, I'll give you a few examples, you categorize them. So first example is that y of t is equal to, I'll give you one tricky example. Y of t is equal to 2 times x of t. What type of system is this? Memory based or memoryless?
Memoryless, ma'am.
It's memoryless. So if I put t is equal to 0, I'll get y of 0 is equal to 2 times x of 0. Okay. And if y of 1 is equal to 2 times x of 1, y of 2 is equal to 2 times x of 2, or y of minus 1 is equal to 2 times x of minus 1, and y of minus 2 is 2 times x of minus 2. Y of minus 2 is 2 times x of minus 2. So what is happening here? Y of t is a function of x of t. Correct? So present output is depending on present input only. This 2, what you have here is a coefficient. Okay, don't worry about this coefficient, just check the x of t, input alone. Okay, so it is a memoryless system. Why? Because the present output is depending only on present input. At t is equal to 1, y of 1 is equal to x of 1. Present output is depending on present input. At t is equal to 2 also same thing. Y of 2 is equal to x of 2. So don't worry about these coefficients. So if you have coefficients also, it's no problem. It's memoryless system because your output, present output is depending only on present input. Got it, everyone? Are you guys following?
Yes, ma'am.
So one more example I'll show you. So y of t is equal to x of t minus 1 plus x of t plus 1. What type of system is this? Memory based or memoryless?
Memory based.
Yes, ma'am.
Ma'am,
Yes.
memoryless, ma'am.
Memory systems with memory or memoryless?
With memory.
With memory. Because if t is equal to 0, y of 0 will be x of minus 1 plus x of 1. So present output is depending on past input and future input. This is x of 1 is future input, x of minus 1 is past input. Okay, so our present output is depending on future input as well as past input. So it is memory based systems. Or you can also tell dynamic systems. Okay, memory based systems are dynamic, memoryless are static. So I'll just give you a few examples. You check if it's memory based or memoryless. So y of t is equal to x of t plus 1 plus x of t. What type of system is this?
Memory
Ma'am, it
based.
needs memory base.
It's memory based because if t is equal to 0, y of 0 is equal to x of 1 plus x of 0 you will get. So present output is depending on future input as well as present input. So it's memory based systems. It's a memory based system or it's a system with memory. Okay, so one more example. It's time up now. Okay, we'll wind up our class and we'll continue with these problems on Thursday's class. Okay, so I'll give you 2 homework problems. You solve it, you try solving. So y of t is equal to e to the power of minus t plus 1 into x of t plus x of t. Yeah, this is one problem. And y of t is equal to x of 2t. You try these two. Okay, and we'll discuss about more problems in our coming
We
class.
should mention only if it is memory or memoryless.
Yeah, it's memory or memoryless. By seeing only you can tell this is, what type of system is this? Second one.
Memoryless.
Memoryless. Y of 0 is equal to x of, so y of t is equal to x of 2t. Y of 0, if t is equal to 0, y of 0 is equal to x of 0. If t is
Memory
equal
based.
to 1, y of 1 is equal to x of 2. Correct? If t is equal to minus 1, y of minus 1 is equal to x of minus 2. So it's memory based system. Got it? Don't judge by only taking t is equal to 0. You have to take t is equal to 1 and t is equal to minus 1 also. Got it? Is it clear, everyone?
Yes, ma'am.
What about this?
Memory based, ma'am.
You think about that. Okay, I'll tell you in next class. You think about this. Okay, guys, we'll wind up our class. You can write your name and USN in the chat box. If you have written, we can wind up this class. You have any doubts till now?
No, ma'am.
Is it clear? Introduction to systems.
Yes, ma'am.
Okay. We'll wind up our class. We'll meet again tomorrow and solve more problems.
Thank you, ma'am.
Thank you, students.
Ma'am,
Yes, Yashas.
ma'am, is there waveform synthesis this sem also, ma'am?
Yeah, you'll have.
Okay, ma'am. Ma'am, in power signals, in energy and power signals, how the questions will arrive, ma'am?
They'll ask whether the given equation is an energy or power signal. They'll give you x of t in the form of waveform or equation. They'll tell you whether it's an energy or power signal. You have to find out. If it's non-periodic, it's energy signal. If it's periodic, it's power signal. Okay.
Ma'am, if it is a purely unit step, then it is power signal, ma'am. If
It's
there is
power
any
signal.
addition,
Yeah, unit step is a power signal.
like if e power 2t plus u of t, in such signals, whether
They
when
won't
it's
give you e power 2t plus u of t. You cannot plot that, right? If you can have multiplication of e power 2t into u of t, but not plus.
okay, ma'am. In
Okay.
such conditions, how to determine, ma'am?
Such conditions you have to split that signal. If you suppose you have a RAM from -1 to 0, then if you have step signal, you have to split that signal. Okay, I'll show you one example. I think I've showed you the such example. So if you have a signal like this, -1 to 0 RAM, and it is stepped till infinity, what will you do? You'll find energy or power.
First, we will find the energy, ma'am. It is non-periodic.
They'll tell you if you have such signal also, they'll tell you to find the power of this power of this signal. So what will you do? So you split this signal from -1 to 0 with an amplitude 1 plus unit step. Okay, what the power of this is energy signal, correct? First one. So
Yes, ma'am.
power will be equal to 0, and for unit step, this one you find out power, how much ever you get. Okay, so you get right that much watts. Or they tell you to find energy of this signal. So find energy of this. Energy of this would be infinity. So they won't ask for that. They'll ask you to find the power of this only. If this is energy signal, so power is 0. Find power for this and write the power, how much ever watts you get for this one. Got it?
Okay, ma'am. Okay, ma'am.
Yeah. You have any other doubts? Okay, thank you, students.